Tonight we're looking at Chapter 7. The topic for Chapter 7 is arrays. These are the 4 sections that are included in the chapter in your book. If you look really carefully at our unit folder on Blackboard, you're going to notice that I don't need you to read actually the whole chapter here. You're welcome to go ahead and do the reading and even try the exercises in the sections we don't cover. But for both chapters 7 and 8, I only need you really to look at the first 2 sections, and those are the only things I'm going to be testing you on, and really even within those sections focusing on the things that are important for the work that we have. You guys should be noticing at this point in the semester that we're getting pretty close to the end. In fact, the sequence of what's coming up is we will be looking at chapters 7 and 8, and then I'm going over here to my other course shell, and you can see after we do arrays and files, we are then moving on to databases. So what that means for us in terms of content is we are looking at chapters in 7, 8 in part, the parts that are important to us. We will be skipping over chapter 9. Not that it's not an important chapter, but it focuses more on different types of controls we can add to our applications as opposed to new concepts. And then we're going to be going to chapter 10, where we're going to spend our last couple of weeks looking at databases. Some database concepts actually get introduced, believe it or not, in chapter 7 and 8 because of the way that we start to structure our data. And I'll point that out as we go. But these are the topics. So sections 7.1 and 7.2 are the sections I'm going to be lecturing on in this PowerPoint presentation. All right, so let's move on to section 7.1. These are the topics within that section, and a few more topics that go with. But let's get down to what an array actually is. An array is basically a variable that can hold more than one thing. That's kind of an interesting thought. What I like to do when I first introduce arrays to people is to actually bring up one of my favorite Microsoft Office programs, which is Excel, and I kind of use it to kind of do a little bit of a demonstration as to what variables are and what arrays are in terms of what they look like. So for example, if I was to create a simple variable, so I'm just going to say a simple variable. And what I'll do is in this area here, I will actually create little outlines. So I'm going to use some borders. So you can see I create a little box, right? And inside the box, I'm going to give the box a name for the variable. And then usually there's a data type that goes with it, right? So we would say num as int, or integer. Right, so it has a name and a data type, and then it also has a spot where I could put in information. So I could put in, for example, the number 5. Now I'll do a little formatting on this just to make it look nicer, but that's basically what a variable looks like to me. It's got a name, it's got a data type, and it's got a place to put something. An array variable is a little bit different. In an array variable, we also have boxes and data types and names. But what's interesting about it is it's got a little bit different type of structure. So, for example, if I was creating an array of numbers as an integer, the structure of it would look something like this. And I'm doing a little bit of formatting here, kind of to demonstrate a concept, but notice that an array has got something interesting that goes with it. It's got a set of parentheses that follows the variable name, which indicates how many positions it has to hold information. And what's fascinating about this is I actually did it wrong right off the bat, which isn't a good sign. But I do have a data type for it, what kind of data can go into the array, and I also indicate a size. So really the structure in terms of what an array looks like is kind of like an extended regular variable. And notice that there's a row of index values. So I might even do something like this here. So if I wanted to put something into this position, I would refer to that position as num0, and then I would put that value in there. So I like to do this before I really go into it, right? Okay, now I see light bulbs going off. Are you being silly, or do you have a question? Yes. Right. So this kind of lends itself well to something that you're already kind of intuitively doing, especially when you start working with loops. And Max, you have a question also? Not the list box, but you know, the list box, when they were doing the loop examples, yeah, they did. And what was interesting about that is every time you had a separate line that would output in the list box, that also had an index value that went with it. So kind of a similar type of approach. But what you see here is one named object with multiple index positions capable of holding many values. And that's called an array. Okay? So you think of it as rows and columns all with one name. So I like to use this as kind of like an image of what an array is. So if you have that in your head as we're working and listening to the PowerPoint, I think that'll help you quite a bit. So just to kind of look at the author's definition now, he says a variable or a simple variable, that's what we first learned, right? You declare a data type, you give it a name, you put a value in there. An array variable has one name with many simple little spots where you can add multiple values, and therefore use one name plus the index value to address all those individual boxes. And that has some advantages when you're writing code. And you probably have encountered some situations already, as you were just talking about, Alec, about how it might be useful. It is very useful structure. All right, so the example that the author starts with here is, suppose you want to evaluate the exam grades for 30 students and to display the names of the students whose scores are above average. So he goes ahead and he starts building a bunch of variables. So he does dim student 0 as a string. There's also score 0 as a double, student 1, score 1. You can see he's going through and he's like basically creating two sets of variables over and over again, right? And he's numbering them so he can keep track of them. Each one requires its own declaration. It's pretty inefficient. So the array way to do it is to basically use one declaration and indicate how many you want. Now, if you go back, notice the number 29, and notice he wants 30 students. And in my example, I created 1, 2, 3, 4, 5, 6 spots, right? And that's what I did here. I declared 6 spots, but the index value only goes up to 5. And you know what? Oh, I made a mistake, didn't I? And see, I kind of do this on purpose to kind of demonstrate a concept. And the concept is that when I say num array with 5, when I'm declaring it, it really is declaring 6 positions because the first counting number for a computer is 0. And that's the thing that will probably throw you off the most as you're getting started and what you want to be the most careful of. So, yeah, when I say num5 is integer, that is 6 positions. 0, 1, 2, 3, 4, 5 means 6 positions in the array. And that's why when you look at this slide, he sets it to 29 because the first position is 0, the last position is 29, which is 30 total. So as long as you remember that, you shouldn't get too messed up. So one declaration for all 30 students, one for all 30 scores. And notice that 29 indicates the upper bound of subscripts in the array. So they call it subscripts. Some people call it index values, array positions. Those are the terms you'll often hear. All right. So how do you put a value into an array? Well, you can indicate the specific array position, kind of like I did in my Excel example, where I say students in index value or position 0, Tom Brown. So it'll find that particular spot in the array and insert this value. All right. So here, the author is trying to give you some terminology, and using this generic statement. It says the 0 bound's always the lowest lower bound of an array, meaning the first index position of any array is always 0. Here, because n is not specified as a number, we say that's the upper bound. That can be any number. The number of elements in an array is n plus 1. So like we saw in the example before, when I say students 29, that means I have 30 positions, and that's why he's got a plus 1 there. So that, I think, is fairly clear. It's just that, remember, computers start counting at 0. It'll make things pretty clear. All right, so we're going to look at a little sample application here. Here's the form that's created. And here's the code that goes with it. All right, so when you click the button, what's going to happen is an array is created. Now there's no real indication that this is an array. It doesn't say like dim as array as string or something like that. It just says team names 3, and the only indicator that it's really an array is the fact that those parentheses are sitting after it. One thing I do want to make very special note of, because many of you will go on to learn other programming languages, the use of parentheses to indicate array structure, I'm not going to say is unique to Visual Basic, but Visual Basic is one of the very few languages that uses that as its designator for arrays. What other languages typically use, so for example, like if you're in the web program or the software program, you'll see that most languages will use square brackets for arrays. Pretty universally. That's a pretty universal thing. So that's just something important to note, and I always like to point out those differences for future coders. But in Visual Basic, the parentheses is the indicator that we're working with an array. So the upper bound is going to be 3, meaning that how many positions are in the array? 4, that's correct. 4 positions, 0, 1, 2, 3, 4. Then we go through, we also declare an integer. Don't do anything with it, we just declare it. And then we go through and one at a time indicate the position in the array and then insert a value. So position 0 gets Packers, position 1 gets Packers. Heck, they should all be Packers, right? Okay, we'll throw in the Bears for the Chicago fans, right? Anyhow, that's how we individually populate each position in the array. And then what the application simply does, if you want to figure out, is you put in who won which Super Bowl. So the first 2 Super Bowls were won by the Packers. That's what this thing is about. So an interesting thing that we haven't learned about yet, but as you have been building applications, you may have accidentally, while working with your forms in graphical view, you may have accidentally double-clicked your form instead of a button, and then it creates a little sub-procedure called the form load sub-procedure. And what the author likes to suggest is that that's actually not a bad place to pre-populate arrays or to create an array, is right when the form loads, especially if it's going to be reading in a bunch of information that's going to be used by the application, or pre-creating a bunch of information that the application is going to use. So if you look at the subsequent slide, a form load procedure, which would trigger right when the application launches, in this case, it would pre-populate, it would create the array for team names and pre-populate it with the form load procedure. Notice that the array itself is actually declared outside of that procedure, right? So it's declared as a global in the application, and then as the form loads, the array positions are populated. And that's a real smart way to put stuff into an array. Instead of waiting until the button is clicked to put the stuff in the array, the stuff is put into the array when the application launches. Therefore, as soon as we do something in the application, the data is all ready to go. All right, so that's just a little bit of an example. Now, the whole concept of initializing data and variables is one of those things where sometimes you create a variable and you give it a value, and sometimes you create a variable and you don't. Same is true with arrays. So we can just declare an array, tell it how many positions it has and what data type it's holding, and not put anything in it right away, because we might not need to, right? But there are scenarios where we do want the information to go in right away, and there's a few different ways to do it. One way to put the information in is what we saw here, which is to declare for each position, like a regular variable, what's going into it. All right? In this other approach, generically he says that we can actually put an equal sign after the declaration, then use a set of curly brackets, and then separated by commas, put in the 4 values. Notice the difference though. There is no value in between the parentheses to tell us how big the array is. What's telling us how big the array is the amount of values that we're passing into it. So if I listed all the Super Bowls, like all 40 or 50 of them or whatever it is now, and I just put in the winner in a list separated by commas inside a set of curly brackets, it would automatically set the size of the array to whatever the length of that list is. So we are creating the array, setting its size, and putting values in all in one fell swoop. And if you're using an array that you need a preset set of values, that's a great way to do it. Why not? I like that approach a lot. I think it's very efficient. It sure takes up a whole lot less space than the approach that you see up here, where you have to use one line for each entry. I think that's a little cumbersome when something like this, which is really one line of text, can do it much more efficiently. So that is an approach that's pretty helpful. Now, one thing that you're going to discover, and the reason I start lumping our chapter on arrays together with text files is because there's some similarities about this. And what really you're going to start to notice is that an array is kind of like a bunch of data that you can use to do a bunch of things in one construct. And a text file is a thing that can also be used to do that as well. Now the reason that he brings up text files at this point is because he starts using examples where text files hold a bunch of text that we read into the program so that we don't have to manually create a bunch of data and then feed it into the program. I hope that makes sense. But what he's telling us is that when we do use text files to feed information into our program, we place those in the bin debug folder in Solution Explorer. Now, that folder is not always visible in Solution Explorer, and there's a little button in the Solution Explorer that you click that allows you to see all the files in your program structure. Typically, the bin folder is hidden. And just to explain what the bin folder is, the bin folder is a spot where the compiled executable files reside. So we have folders where we put our source files, right, the code files that create the application. But after the application runs its debugger and compiler and converts our code into what the machine can do, that's compiled code, it's an executable, and it gets placed in that folder. In order for a text file to be read by the program, it needs to be placed in the same spot where the executables are, and that's inside the bin folder, and more specifically the debug folder inside of it. I'll show you when we actually get to do some examples here in class, and that'll make more sense to you. So the reason he mentions that is he's got a file somewhere that contains the ages of the first 44 U.S. presidents. And it's just listed in a text file. And the way the text file is put together, it'll just have 57 on one line, 61 on the next line, 57 on the next line. And when you start to think about it like that, that each line, wow, that's kind of like a separate position in an array, and the text file is kind of like the array itself, right? So you can see it's kind of like a little bit of a correlation there. So there is a technique, and we're going to build up on this technique when we get into the text file chapter, which is chapter 8, but we get a little bit of a preview here. So assuming that we put our text file in that folder within our project, we can then call this command. Notice we are setting up the array, we're not declaring a size, we're putting in the equal sign, and instead of doing the thing with the curly brackets and then values separated by commas, we're allowing a tool that's built into the environment where the I/O file mechanism, and it'll basically I/O stands for input output, and then there's a tool inside of that that allows us to read files. That goes through, it reads all the lines of the text file, and each line in the text file ends up in an individual array position. So that's kind of cool, right? So instead of having a list of all 50 presidents or whatever it is, kind of like the Super Bowls, we have a text file that holds all those values and reads it in automatically. I'm sorry? What would it call each value? Oh, the name would be basically age, this str ages. And then each age of each president would go into, like the first one to go into position 0. So for George Washington, str ages 0 would be George Washington's age. And then each one, and that would read in automatically. All right, so once you would actually read all that stuff in to the array, so just make sure that you can conceive that, then we set up a second array. Notice the number of positions because we know how big the array is. And what that's going to do is it's going to receive all the stuff that we pulled in to the other array and convert it into a number. Because what we're reading in from a text file is text, right? But we need, in this case, or for whatever he's doing, he needs to convert it to a number. So you'd actually have to set up a second array and then take the contents of the first array, run it through a for loop, one index position at a time. So from position 0 to 43, we read each one of the array values, convert it to an integer, and then store it in the other array. Yes, there are shortcut ways to do that without taking that second step, but he's just showing you the technique here, that because when you're pulling stuff in from a text file, you are pulling in text. You are not pulling in numbers, even if they're numbers. They still have to be converted to numbers. So that's something you need to know on the front end before you go in. Now, interestingly, arrays, like many other objects inside of Visual Basic, have a bunch of methods and functions that go with them that allow them to do special tasks. So if you create an array and then append to it one of these keywords that you see here, and there's many more, but these are some of the key ones that we use. So if I have an array and I add to it .count, that counts the number of spots in the array. Sometimes that's a very important thing to do before you take subsequent actions. Like you don't want to run a loop one too many times and the array is like shorter than what you're running the loop, and then you know what happens to your loop? You get a problem. You get like errors. The program will crash, believe it or not. So sometimes we'll run a count first to see how much you're doing. You can also look through the array and find the biggest and smallest values, or what the first element is, or what the last element is. And like I said, there are many more things that you can throw in. So, little tip as well, the upper bound of an array is determined by count minus 1. So remember we had the students, we had 30 students. So if I did array name.count for that student array, what it would do is it would come back with a value of 30. But if I want to find that last position, the last position is actually 29, thus the minus 1. So you got to be mindful of that little offset. Remember, computers always start counting with 0, and that should hopefully help you to avoid that problem. At least I would hope. All right, methods for numeric arrays include some mathematical functions. So if you have an array full of numbers, there actually is a method built in that will give you the average of all the numbers in the array. That's pretty handy. Now I know I have some assignments coming up for you guys where you might be tempted to use these, and in fact maybe you'll find a way to use it. And there's also one for sum. That's kind of cool that those things are just built in. Why are they built in? Because they're so common to do. It's very common to total things. It's very common to average things. Once again, you'll also find there's lots of other methods that are built in that would be helpful. Now, having a tool where it's built in, it can automatically do an average or a sum for you or find the biggest number, that's really cool. But he also points out that it is possible to use loops to do some of these functions as well and do it programmatically. In fact, that's most likely how these methods work. So what he does is an example here on the next slide. First line creates an array of integers and then hard codes the birth dates of the last 9 presidents. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So the last position here would be ages, the number 8 inside parentheses. That's how we would address it. Position 0, 1, 2, 3, 4, 5, 6, 7, 8. Then he declares a variable called max as integer. He presets it, notice, to the first array position. So he's just saying the biggest thing in the array is the first array position. Now he's got a logic for doing this. Okay? He's presetting it to the first value because then he's going to run a for loop that's going to run from 1 to ages count minus 1. So he's looking at this array. It'll count 9 positions, subtract 1, and run up until ages 8. See the logic there? So it runs from 1 to 8, which are the positions that are available in the array. Now he doesn't start at 0 because he already stored the value for 55. So the first time he's going to come through, he's going to look at the next position, 56, and then say, is 56 greater than 55? It is. So now he's going to say that the new max is 56, and he's going to keep running through the loop. The next time through, 61 will be the new max. 52 will not. 69 then will become the new max. 64 will not, 46 will not, 54, and then ultimately it will output 69 as the greatest age. See how that works? All right. I know that can be a little bit confusing initially, but arrays are pretty fun, and you can do a lot of stuff with them. And you'll see very often that arrays are teamed up with loops, because when you have a whole bunch of things inside of a structure like that, sometimes you need to step through it methodically and pull out the values or insert the values or change the values, and an array and a loop go hand in hand in that capacity. All right, so you guys learned a dim statement. Well, here's your chance to learn a ReDim statement, right? And what a ReDim does is it allows you to change the size of an array after it's already been declared. However, it can have a little bit of a side effect, right? That can be a problem, and that is when you resize it, it tends to blow away all the data inside of it. That isn't very good when you want to keep the data inside there. So what they do have is a thing called the preserve keyword. So you would use ReDim preserve, put in a new value, and it will retain as many values as possible, whatever that means. I never liked that wording. You know? Hopefully it retains everything that was already in there, right? I don't want to lose any of my information. But that's what it does. So if you want to expand the size of an array, that's one way to do it. Now, interesting thing is there was this loop construct that we learned that was called a for loop, right? And there's an additional loop structure which really is designed to work with text files, databases, and arrays, and that is called a for each loop. So the top loop and the bottom loop do exactly the same thing. This is what's interesting about it. The top one, I declare a counter and set. I'm going to go from the first position to the last position in the array. And really it's not the first position in the array, that's actually the second position in the array, but I think you get the point. Where the bottom one automatically recognizes that it's traversing some sort of a pre-built structure and just says, for each one of the things in the structure, loop. So as long as I have array positions, keep looping. As long as I have entries in the text file or in the database, keep looping. I don't need to do a count. It just does it. So for each is a nice little shortcut, and that's one of those structures that exists in most programming languages as well. All right, a couple little tips on them. These aren't really all that important. Basically saying that you can use anything as a variable name inside there. Not a big deal. So some questions that some people normally have when you're working with an array is, can I take something that's in an array and pass it like I do a regular variable? Absolutely. So in this case, you know, we do have some sort of an array structure that's got 21 positions, right? And we're passing or assigning a value of 10 to the 5th position, and then we're using that 5th position value and passing it just like we do a number. All you have to do is just say the array and the position, and you can move it around like any other piece of data in an application. It doesn't really matter. Can also, like other data structures like an integer, you can also return arrays as well as you could like an integer or a string. The only difference is that you include at the end of the statement the parentheses. And that way you can actually send a whole array to something and return a whole array to something. So you can move it around as a complete object as well. All right, there are ways to actually search through arrays, and one way to do that is by using this keyword of index of, And notice what you do is you throw the array name at it and whatever the value is. So what this would do is it would say if I had an array called presidents and I was looking for the value Trump, it would look through my array, find the value Trump, and return the index of that value. So if Trump was stored in position 45, right, he's the 45th president, that would return the value of 45. All right. So sometimes that's important because if you're going to be manipulating the data, you need to know where that data sits in the array in order to manipulate it. All right. Interestingly, if you have arrays that have the same data type, you can actually make copies of them just like this. Notice the absence of the parentheses. Some useful methods that go with arrays. One is a split method. And I think the way to see this best, honestly, is just to see it in action. But what this does is it looks for a way to split the array, and it's looking for a delimiter. And basically, the comma becomes the delimiter. In other words, the thing that we will use to separate the values. So notice here we have Bob, comma 2350, comma 45. If I run this line split on that string of text, it will then break it into an array. Not anything you're going to be tested on, just kind of interesting information. All right. And you can see how I'm skipping over a bunch of stuff, right? Because now we're getting to the efficiency part of it. We're just going to look at the stuff we need. There's also a join that basically allows us to take something that isn't in an array, and then we can just run a join with a comma and then add it onto a structure that pre-exists. I think I already talked about this. You can pass entire arrays back and forth between functions, and that's really about all I'm going to say about it. And then I'm going to jump down to slide 41 here. And one thing that you might find as you're working, especially with those index values, like counting how many positions you are and what the upper bounds of an array is one of the compiler error messages that you might get is this thing that says index out of range. So like if you're like trying to pull back a value, so for example, he's got an array of trees declared, and there's redwood, sequoia, and spruce. That's 3. The upper bounds is 2. So we have positions 0, 1, and 2. 3 total positions. But then in the next line, he's trying to put something or grab something out of trees 5, which doesn't exist, so it'll throw an error like this. Now, let's talk about that. Errors are a problem, right? Especially when you don't know what the size of an array is. So that can really kind of mess you up. So we are going to start talking about in the next chapter how to deal with situations where the input that you're getting or the information that you're dealing with isn't optimal for what you're working with, to try to keep a program from crashing. Because anything like this, I mean, this would stop a program dead in its tracks if you're trying to run it. In fact, it won't even run in this case. So that's not a situation that we want. We only have a few more slides to look at, and normally I would save this information for the database chapter in its entirety, but I do want to introduce it to you here. LINQ, or LINQ, is basically a format for doing queries. Now here's a question for you, right? And this is a database thing. A query is a question, whenever you hear that word. And what Visual Studio has added to it a number of years back was this thing called LINQ, which allows us to work very eloquently with a few different programming languages and do database queries without formally learning how to do SQL statements. So in other words, using programming code to be able to interact with databases as opposed to using database code to interact with databases, which is more the old-fashioned approach, but still very important. And LINQ stands for, it says Language Integrated Query. So right there from the description of it, it shows you that it's integrated into the programming language as opposed to being some separate language. Like if we were using a proper query language like SQL or SQL, some people call it, we would actually write it in a separate language, surround it with quotes, and then send it off to the database for interaction. What's interesting about LINQ is because it's built into the programming language, it kind of takes away that overhead and lets the programming language kind of handle that all in the background. Now, the neat thing about it is that this allows us to interact not only with databases, though, because of being integrated with the language, it also allows us to interface with arrays and text files, too. So that can be a very useful thing. Note that it does have this little thing that there's a setting, just like we have like option strict, there's an option infer that has to be set to on. That is the default for Visual Studio in order to be able to use LINQ to do any work. In its very, very simple form, what you're going to see with a LINQ query is that you typically will set up a variable that will hold the query. So that variable is a special type of structure, and it basically goes through and it pulls in information from your array, and it looks for a particular item in a particular array where certain conditions might be true, like Trump or Packers or something like that. And then we are then allowed to select a particular value if the conditions are met from that certain array. So it's kind of like saying, was there a president called Smith? You know, a lot of people wouldn't know the answer to that, right? So we'd run the query and it would search through and it would find Smith and pull it back and say, yeah, it's there. So that's basically what a LINQ query is. Now, sometimes when you run a query will return not just one result, but many results, in which case what it returns can be actually converted to an array, put into a list box, or written to a text file. And what's interesting about all three of those structures is all of them have array-like indexing, like we looked at real briefly in the previous chapter. All right, that's as far as I'm going to take our lecture here. So I know there's another 100 slides to go or something like that, so you guys are probably breathing a sigh of relief, because when you're looking at the slide count, it's like 97 slides, oh my God. Well, that's actually all I'm covering in this chapter. If you want to read up more on LINQ queries, please do. We are going to revisit those when we get to chapter 10, where we will use them pretty extensively to interact with our databases. But for now, that's all the information that you need to be able to do your homework and to pass any test I might throw at you. So this concludes the lecture for chapter 7, and we are going to take a break.